Hey, welcome everybody. So cloud is about sort of moving computers over the internet and accessing them at scale. And it's, a user of cloud can get more computers or release computers, and they pay exactly what they need. And meanwhile, the cloud provider can purchase computers in large quantities, can locate them where power is cheap, where it has good networking bandwidth. So the economics become really compelling. A lot of people believe that the future of all computing is going to be in the cloud. Decade from now, we may not be able to buy a computer unless we just rent it out of the cloud. So that's great. Next slide, please. We've had this really unique opportunity. The institutions in this region, so Boston University, Harvard, MIT, Northeastern, and UMass, together built a data center, a unique data center. It's 1.5 acres, it's 15 megawatts. It's got capacity that's available to no other group of institutions around the country. And so we had a unique opportunity to build a cloud there, a cloud that could be used by hundreds of thousands of students. The economics are really compelling. If you look and you take a computer, or $1 million worth of computer, you amortize it over 3 years, the cost of it, the cost of an administrator, it works out to be about 20 times cheaper to have a computer that we stand up rather than buying the equivalent computational power in the cloud. Storage and networking are even a better story than that. So if we could create a cloud that was cost effective, that would enable much more economic research computing. For us as cloud researchers or security researchers, or even as AI researchers, it gives us the potential to transform the infrastructure, to do research into the plumbing of clouds. We don't want a world where in the future there's only 3 entities that control all the world computing. So it's been really powerful because we've been able to apply as a group of researchers for grants that you couldn't do unless you had your own opportunity to do that. And the side effect of that is most of industry is actually not able to participate in the public cloud. So we've had enormous connections from a whole bunch of companies who've wanted to participate in our cloud. So it's led to a whole bunch of NSF, NIH, and industry grants. It's led to the Red Hat Collaboratory and hundreds of computers donated by different partners of the MOC. Next chart, please. So today it's relatively modest. It has a bunch of core partners involved in the effort. It supports dozens of researchers doing cloud computing, and it supports about 400 users on average at any given time, and about 10,000 users of services stood up by that. So we're pretty happy. It's been sort of successful at a modest scale. Next chart, please. And this has really been sort of a stone soup kind of effort where different entities have helped stand up all kinds of different capabilities. We have about 2,500 cores of compute, of standard Intel compute, about 1 petabyte of storage. On top of that, we stood up storage services, VM services, container services, and actually recently we've moved towards a productized service to allow you to actually acquire physical machines for deterministic research. That's been the participation of a whole bunch of companies that have actually worked with us to stand up those different services. Next chart, please. On top of that, Red Hat recently sort of made available an AI as a service offering, Open Data Hub. And it's actually really exciting because they want this to be a product. Out of their experience with doing this, they realized they really need to stand up services with real users to real customers before they start releasing these things as product. So they're moving towards operate first effort where every product that Red Hat's going to be released will first be operated on the MOC before being released as product. Next slide, please. IBM last year donated a bunch of servers with 1 terabyte of memory in each, 40 NVIDIA GPUs, massive bandwidth between these. We've been staying up OpenShift and different services on top of that. And so this is an awesome platform for AI. Next chart, please. And Harvard Dataverse is actually moving off of AWS. So this is the largest data set repository for a broad set of data sets. And that's actually moving off of AWS onto the MOC. And this will allow them to host large data sets and actually download them without paying egress costs from AWS. Next chart, please. Finally, the Northeastern Storage Exchange, which isn't us, but is a group that's working closely with us, standing up a massive data lake, so 20 petabytes. And again, the cost here is a fraction of the cost of S3. Next chart. So this is the project as it sort of existed, I guess, early last year. You know, as I said, a modest group of users, core set of partners, and a set of cloud researchers. Next chart. In October of last year, we got funding from the NSF to create the Open Cloud Testbed. So this will be a national testbed for cloud computing research, opening up the MOC to, you know, all the size researchers across the country. As a result of that, some of our industry partners added another 200 servers to the MOC. So this is actually reaching one of the largest test beds for cloud computing research almost from its inception. Next chart. So open source is difficult. It's really hard to operate this stuff. Those of you who have been our users have seen a number of failures over the years. We went to talk to the OpenStack Foundation about this, and we thought they'd be kind of offended, and they were really excited about it. We said, you guys really need a cloud to be standardizing things, to be prescriptive with. The Open Infrastructure Labs project was announced late last year, and we're giving a keynote in front of 10,000 people next week, so I'm a little nervous. This is a project which will actually, industry can participate with us to create prescriptive efforts. The goal is to actually standardize those and then replicate them to different academic institutions to start off with, so they're federated together. So this is going to broaden the MOC way beyond the core partners that we have today. Next chart. And this is perhaps the thing I'm most excited about the transformation, is that this has been a soft money project, a research project. Now we have BU's Research Computing and Harvard Research Computing are working together to create a production offering that will make this available not only to a much larger community that doesn't have the skills necessarily of people who've been able to use the MOC so far, but is actually, you know, professional research computing staff that have facilitators that can work with scientists to transform their computation to use the cloud. So we're really excited. All these efforts that I just talked about sort of came about since October of last year, and it's really expanding dramatically what we've been doing. And I think the key part about this is we're in a unique position in this area to do computing, to do research in an area that nobody else has access to a real operational cloud. Next chart. Oh, yeah, I forgot about this. And then finally, Red Hat has denounced their operate first policy, which is, as I said, around their AI platform. They want all their products to be first operated by Red Hat with users from academia on top of the MOC and operated in so they can test them with real users before they release them into products. So that's a really huge infusion, and all this is resulting in, I think, a dramatic expansion, which I hope we'll be able to announce soon with the Red Hat Collaboratory. That's it.